Got my farming hat on. Let's get in the dirt and configure some VLANs. I'm hoping at this point that you've launched the virtual lab, clicking the link in the web interface so that it can be building while we talk through the instructions. Also note, I have no idea how to say VLANs with a southern accent, or even why I'm using a southern accent at all when I'm doing this. VLANs, got your VLANs. So here's what the lab is, and it always behooves you to read through the lab objectives before you do it, because oftentimes later steps can change the way that you approach the early steps. So in this lab, we've got PC10 and PC20 that are connected to the ports displayed in the diagram. Those guys right there. You currently have access to PC10. This PC, it's, CEO's. He's like, don't touch my computer. Because he's also Southern. And he says, okay, document the IP address and gateway of PC10. So right now, the IP address of PC10 is not this right here. It's something else. We need to document that. Then assign PC10 the IP address 1016.220, which is this IP right here, with no default gateway. Then view the current VLAN configuration on access 1. That's the only switch we'll use in this lab. And based on that configuration, will PC10 right now, just based on the configuration that's there, do you think be able to ping PC20? So test your theory. See what you think and then test it. Then create VLAN 10 and 20 on the access 1 switch, build the VLANs, and assign the ports allocated to actually both of them to VLAN 20. Now, once you do that, question will be, do you think they'll be able to ping each other right now? Why don't you try it? Test it out. Finally, configure the PC10 switch port, which is this guy right here, to be in VLAN 10. And then based on that new configuration, do you think they would be able to ping each other? Test your theory. Good. So what I'd like you to do is pause the video, run through this lab. I'll put the steps right back up there so you can keep that frozen on your screen. Run through it yourself. See what you can accomplish. And my goal is that you'd be like, I'm awesome. I'm done. And you close it right there. But if not, no worries. I'm gonna keep going after the pause and do a walkthrough for you. So if you have any questions, get stuck, just want to see my perspective, you can watch that whole thing. Okay? Ready? Go ahead and pause right now. Good. Hopefully that you did. Hang on, let me clear off all the chicken scratch. There we go, and get this going. So first step is to document the current IP address and gateway of PC10. So bringing the lab up, it looks like we've got access on two different devices. DC NUG is our access 1 switch, and our client PC, that's our PC10, right? So we'll get logged into this guy, PA$W0RD. You can see the password over there on the right-hand side. Hit the enter key and welcome. So we're getting logged in, and we'll go to Cortana and get a command prompt opened up. We'll do an IP config, and sure enough, current IP address 10.16.0.10. So let's write that. Current IP address is 10.16.0.10, and gateway is 10.16.0.1. So 10.16.0.1. Okay, good. Number 2, assign the PC10 the IP address 10.16.2.20, which is this one, with no default gateway. Cool. Let's go right here. Open control panel. And if you could type it right, there's many ways in Windows 10 to change the IP address. This is just the way I always have and probably always will do it. Get to the LAN adapter, double click the IP address 10.16, oh, what was it? 10.16.220. 10.16.220. And delete that default gateway out of there. Don't need that. DNS, we can leave that there. That won't cause anything. Or you can delete it, whatever behooves you. Shrink. Get the, not that guy. Let's get that guy brought back up and verify that we've got the new IP address assigned. Good. 10.16.220. Okay. Now let's go back here. Done. So let me get my little checkbox here going. Okay. Good. View the current VLAN configuration on access 1. And based on that, should PC10 be able to ping PC20? Let's have a look. Go over here to DC NUG. And by the way, one of the things, if you haven't found out, you will, we restrict access in all these labs to the show running configuration command. The reason for that is this is a lab environment, and as such, we want you to learn certain things. And you'll find on many certification exams, Cisco also restricts your ability to use show run, because if you know something's wrong, you probably know somebody tweaked the configuration, and it's usually easy to spot not knowing that much, looking at the running config. So the message is, we want you to be a real troubleshooter. Use real troubleshooting commands, not just looking at the config, knowing something's wrong, because obviously that's not very real world, right? So show run is not an option in any of these labs, and we'll do instead do a show VLAN, because that's what we're after. And I see right here, VLAN 1 is the only VLAN that's really active. Hang on, let's do a show VLAN brief. VLAN 1 is the only one, and it looks like all the ports of this switch are assigned to that. There are no other ports right there. Okay, good. So, okay, default config. So what was the question? It says, based on the current config, should PC10 be able to ping PC20? So hang on. Current config is this guy's in VLAN 1, and this guy's also in VLAN 1. Okay, so looking at the VLAN, looking at the subnet, I would say, yeah. I'd give it a check by thumbs up, because same subnet, same VLAN, you should be communicating just fine. Let's test our theory out. I'll come back here to the client PC, who is 10.16.2.20, and I will do a ping of PC10, which was 10.16.2.10. 10.16.2.10. Let's see what happens. Yeah! Theory proven. Same VLAN, same subnet, same communication. So we can do that. Yes, our theory was correct. Okay, so now create VLAN 10 and VLAN 20 on the Access 1 switch. Okay, can do. So come back here to DC NUG. Right now there are no VLANs. So I'll go and type in VLAN 10. And by the way, you could just leave it at that. If I do a show VLAN, you'll be able to see it creates it just with the name VLAN. I can't stand that. I love having names under my VLAN. I know where this is going. We're going to have the name static or server or something like that as this. So I'll assign that name right there. I'll go into VLAN 20 and do name. I think that's going to be voice over IP when we're all said and done. So I'll back on out. I'll do a show VLAN. And yep, those two are both created. Static and voice over IP. Cool. So check. Now, assign both PC10 and PC20 switch ports. So that's these guys right here to VLAN 20. Okay, can do that. So let's go into global config mode, and I'll do interface G0/0 switch port mode access. I always do that when you're going to assign a VLAN, because that's what says this is a computer, a single VLAN device, switchport mode access, and we will say switchport access VLAN 20 is what we're assigning it to. Good. Hit the up arrow. Go back to it was GI 1/0, and there we go. Switchport mode access. Hit the up arrow, switchport access VLAN 20. We've now switched those over. Okay, so now that they're both in VLAN 20, should PC10 be able to ping PC20? I would vote yeah, because we're moving this to VLAN 20. Again, same VLAN, same subnet, not our end configuration, but let's give it a whirl. So I'll come back here and hit the up arrow. And right. Oh, I bet what's happening is spanning tree protocol. Spanning tree will keep your ports. I hope it's spanning tree. It'll keep your ports frozen for a certain amount of time. It puts them in kind of a suspended state for about 30 seconds or so. Right. Okay, good. I was getting worried there for a second. There we go. It came up. So don't worry if you go too fast on testing that. It takes a sec for it to come up. Okay, so yes, our point is proven as true because they're both in the same VLAN, VLAN 20, and they're both in the same subnet. If those two things match, bada bing, you should be good to go. Okay, now last step, configure the PC10 switch port. So that's, hang on, let's just erase all this stuff, get a little cleaner slate. PC10 switch port in VLAN 10, right? So that'll be its VLAN. So that port goes in that VLAN. And this guy remains in VLAN 20. Okay, based on this new configuration, should PC10 be able to ping PC20? Well, at that point, I would say absolutely no game. Because if either of these mismatch, if you've got the wrong subnets or the wrong VLANs, then you're not in the same network, right? So VLAN 10 and VLAN 20, different VLANs, even though the subnet matches. So let's give it a whirl. I'm going to come over here. And let's exit back out. And the port for PC10 was gig 0/0, right? Yep. So I'll go back into interface G 0/0, hit the up arrow switch port, access VLAN 10. And I'll come back and verify that that took effect. Show VLAN. I can see that both of those are in their own little switch port right there, their own little VLAN world. And now let me show you what I was talking about with spanning tree. I bet you this is what's happening. I'm going to do a show spanning tree. And let's do for VLAN 10. And you can see right here. Yeah. Take a look right here. There's our port that's connected to our PC10. And notice status is blocked, meaning it just switched over. It's just now initializing spanning tree. Spanning tree makes sure that you don't have loops inside of your network. It's a big topic, big skill later on. You really want to see that. So good, so good. But we're just going to kind of wait this one out. We'll hit, okay, so right now it's transitioned from blocking to learning, as in it's learning the MAC addresses that are assigned to that port. This process takes about 30 seconds. So I'll hit the up arrow. Okay, there we go. Now you can see the status has changed over to forwarding, but the result will actually be the same because since they are in different VLANs, you're not getting anywhere. As a matter of fact, you can see right there, request timed out. I'm going to do an ARP-A. Okay, so you can still see it has the cached IP to MAC address mapping. Remember ARP, Address Resolution Protocol? That's what it does, is it figures out what MAC addresses these devices have. I'm going to clear that. Actually, I might have to elevate my permissions. Yeah. So I'm going to open a command prompt as the admin. Right-click on that. Run as administrator. Yes, that's fine. And now I'll do an ARP-D star and clear that table out. So now when I hit the ARP-A, yep, all that's left is that guy. Now, if I go back and hit that ping command again, it's still trying to ping. My whole point is I want to prove to you that if I go back and do an ARP-A again, it's still not there. Meaning the VLAN is completely cutting off communication between those two hosts. This isn't between these two hosts. I got to slow myself down. This isn't an IP address thing. It's not like, oh, they're just on different IP. No. They're on the same subnet. VLANs are a layer 2 thing. ARP is a layer 2 protocol, right? It is resolving the IP address down to the MAC address. So if that's not even working, then you're hosed. You've got your guys completely in separate domains, and those two are not communicating in any way, shape, or form, which proves that our VLANs are doing exactly what they should. Good. Well, that said, that is VLANs on a single switch. Hope this has been informative for you. I'd like to thank you for viewing.